Hi, today we are doing lesson 3 and it will be equivalent ratios. Our first exercise asks you to write a one-sentence story problem about a ratio. What I want you to do is think about a ratio, perhaps something in your own life, and go ahead and write it in one sentence. The second part of that is to write the ratio in two different forms. That's using a semicolon as well as the word to. So go ahead and take a minute and do that now. Okay. On to exercise 2. Shani and Mel are using ribbon to decorate a project in their art class. The ratio of the length of Shani's ribbon to the length of Mel's ribbon is 7:3. Take a minute right now and write down on an Edpuzzle what this problem is about. What's going on in this problem? What's your understanding of this problem? Now the next thing we are asked to do is to draw a tape diagram to represent this ratio. But before we do a tape diagram, let's try with a table. Let's make a table and let's have our table represent the information that we're given. So we first need the length of Shani's ribbon, and let's just type that right in here, in inches. And then we're going to need the length of Mel's ribbon in inches and the length of Mel's ribbon in inches. Now we need to go back to our information. Remember that the length of Shani's ribbon to the length of Mel's ribbon is 7:3. Shani's ribbon came first, so our first number under Shani's ribbon is 7. And Mel's ribbon came second, so that's where the 3 comes from. So before we do a tape diagram, we're doing a table here. If we have, Shannon has 7 inches, and then Mel would have 3 inches, if we were to continue on with this, Shannon would then have 14 inches, and so Mel would have another 3 inches, so that would be 6 inches. And if we were to add another 7 inches, that would then bring us to 21 inches for Shannon's ribbon, and we would add another 3 inches, so that would bring us to 9 inches of Mel's ribbon. So before we move on, this is our table, and we're about to make a tape diagram. Now I'm going to show you how to do it on the document, but you can either do it in your document using drawing the way I will, or you can draw it right on your paper, probably around the same time. Now, working with a document, this can be a little tricky at first, but it's not really that hard when you start working with it. Go up to Insert, and then go to Drawing. And then what I found the best way is to come up here where we have Shapes, and pick a shape. The tape diagram is usually in the shape of a rectangle, and then put it right here. Just about the size you want it to be. So that's 1, but we need to have, how many for Shani? We need to have 7. So one thing I can do is try copying this, going right next to it, and getting another one. And then I can move it right next to, you notice that that line comes in? There's our second one. And now I'm going to Command V and make another paste of it. Come up here, when the red line, it shows us that it's lined up, that's 2. Come over here, do it again. This is 3. So this isn't too bad when you figure out how to do it. Getting the size you want is kind of important. So I have so far 1, 2, 3, 4. I need 3 more to make 7. One, 2, 3, 4, 5, 6, and here's my last one. This represents Shani's. Now, I want to remember when I'm representing Mel's that she has 3. So on the bottom, I'm going to go ahead and do another one. And I'm going to have this one represent Mel's. And I'm going to do 3. And this is a tape diagram. So every time Shani has 7 inches cut, Mel has 3. If we were to continue this tape diagram, we would then continue by adding 7 more, And then on Mills, we would add 3 more. So let's save and close this one for now. And here it comes right on your document. So that is how we start off with what's called a tape diagram. Now looking at this tape diagram, what can you tell me that each one of these units represents? When we don't have the measurement, we refer to each one as a unit, but we were given a measurement. Our measurements for this week, for this lesson, were inches. So therefore, each one of these represents inches. What then does the entire length of this tape diagram represent? What is the length of this tape diagram? And what about Mills' tape diagram? What if the units of measure weren't inches, but instead were meters? What if this was 1 meter? And what if this one was 1 meter? And each one was 1 meter. What then would our length be for Shani's and for Mills' diagram? Well, the length would be 7 meters and then 3 meters. That's not too hard. What if each unit on the tape diagram, each unit, represents 2 meters? Then, what are the lengths of the meters? The length of the meters would be 14 for Shani, and Mel would be 6. So if that's the full length of the meter of the ribbon, full length of the ribbon, which would be if we did it in 2 meters each, then what's the length of Shani's ribbon to the length of Mel's ribbon? What's the new ratio? Or is there a new ratio? Is it 7 to 3 still? Or has it changed from 14 to 6? What if each unit represents 3 inches? What are the lengths of the ribbons then? If this was 3 inch, and this was 3 inches, and this was 3 inches, and this was 3 inches, well, we know that 7 times 3 equals 21, so this one would be 21, and if this was 3, and this was 3, and this was 3, 3 times 3 equals 9. If each unit represents 3 inches, and this is 21, and then this is 9 inches total, then what's the new ratio now? Or is there a new ratio now? Interesting questions. Well, we just verbally discussed, and you guys wrote it on Edpuzzle, we explored 3 different possibilities for the length of the ribbons. But did the number of the units change on our tape measure? Did we change the number of boxes that we had here or here? These units didn't change, did they? So what do these 3 ratios then? The first one we worked with was the original 7 to 3. And then we came up with 14 to 6. And finally, 21 to 9. What do all 3 of these ratios have in common? Well, let's look at this in this way. Here I've drawn in all of our tape diagrams with the measurements inside and our total. So when when each unit represented 1 inch, she had 7 inches total in the length of the ribbon. And Mel's ribbon was 3 inches, represented by 1 inch units. The ratio then was 7 to 3. Notice we didn't put in our measurements because when we write the ratio, we don't. When Shani had each unit representing 2 meters, the total length was 14 meters. And then when Mel's unit each represented 2 meters, then it was 6, she had 6 meters. The ratio then was 14 to 6. In Shani's, when each unit represented 3 inches, and we had 7 of those, we said it was 21 inches in total length. And Mel's ribbon, when each unit represented 3 inches, was 9 inches. And that ratio was 21 to 9. Now I asked you, what do all of these units all these ratios have in common, and mathematicians like to say, or have said, and is true, that these ratios are called equivalent ratios. Equivalent ratios. So let's write that down here. If we go all the way back up to the top and look at our table, we can see how these ratios can be equivalent. 7 is equivalent to 7 to 3 is equivalent to 14 to 6 because you're multiplying both of them by 2. 21 to 9 is equivalent to 7 to 3 because you're multiplying both 7 and 3 by 3. And that's what we did down here with our tape measures. So these ratios are considered equivalent ratios. Okay, now let's look at exercise 3. Now let's put exercise 3 on one page here. So, Mason and Laney run laps to train for the long distance running team. The ratio of the number of laps Mason ran to the number of laps Laney ran was 2 to 3. First thing we always need to do is say, what exactly is this problem about? What's happening here? Well, we know that Mason and Laney are runners, that they run laps to train for a long distance running team. So they run distances. The ratio of the number of laps, these are the distances, Mason ran to the number of laps Laney ran was 2 to 3. And if you've ever seen how teams will practice, they practice on a racing track. So I have in my mind a picture of a racing track right now. And Mason runs 2 laps, and then Laney runs 3 laps for his every 2. Okay, we know what's going on. A says, if Mason ran 4 miles, how far did Laney run? Well, we could think about that, but there's more information. Draw a tape diagram to demonstrate how you found the answer. Well, we could do that. When we do our tape diagram, we have to go back to our ratio. Our ratio was 2 to 3. So let's start by inserting a drawing. Because I've done this before, I know that I need to find a shape and figure out the size of the shape about there. And then I will copy that shape with Control-C. I will make another one. And this will represent, if we go back over here and look, can we move our drawing? No, we can't. 2. And then we need to do another one that has 3. All right, so here's our ratio. Let's make our tape diagram match. Yes, so here's our ratio, 2 to 3. We'll put that right in here. Okay. And let's take it and copy it. And put it over here. Okay, so we know that we have a ratio of 2 to 3. We know that Mason ran 4 miles. Well, the first ratio, we should probably label these, is Mason, because Mason ran to the number of laps Laney ran. So let's go back in here and let's put some names in here using a tape box. Mason ran 2, so we're going to put Mason's name right here. And Laney ran 3. So we're going to get another one and put it in right here. L-A-N-E-Y, I think that's correct. Ran 3. Okay, let's save and close. Put it right back here. Now we have Mason and Laney. We can make that bigger if we need to. We can move it down a little bit and then make it a little bigger. Okay. So we know that Mason ran a total of 4 miles. So our length here would be 4 miles. Let's go back in here again. And just like we did with the other one, we can put down here our total length is 4 miles. Now, if our total length is 4 miles, what could each unit represent? I'm going to say that each unit can represent 2 miles. And let's see if we can change our font size, and we can. And now it should all fit in there. Here we go. 2 miles. Or we could just do this too. Put our tape diagram back. Come over here. Put in 2 mi for miles. And then we can still change our font size so it doesn't have to be quite that small. 12 should do it, yep. So if we keep it at 12, we can be able to fit in our 2 miles. So if Mason, each unit represents 2 miles for the ratio, then we remember from doing this before that these also have to represent 2 miles. And I have to do this again, sorry about this. There, now I put in 2 miles. Well, now we have our answer. How far did Laney run? 2, 4, 6 miles. Let's save and close it and see if we've answered the question. If Mason ran 4 miles, how far did Laney run? Well, if Mason ran 4 miles, Laney ran 6 miles. Wow, this tape diagram stuff really works out pretty well. All right, if Laney ran 930 meters, how far did Mason run? Draw a type diagram to show how we could find this answer. Wow. So we go back, we can go back in here and draw again our 2 to 3, and then this time we have to figure out if Laney ran, instead of 6 miles, we have to put 930 meters. So take a minute to try to figure this one out on your own. Do your own tape diagram, either in drawing if you're working on the document, or do it right on your paper. And see if you can't figure out what numbers would go in here if Laney's was 930 meters. Good luck. Okay, hopefully you did 2 tape diagrams the way I did here. And when I did it in the drawing, I put 3 of them here for Laney and 2 of them for Mason. Laney was 930 meters, so the way that I figured it out was I said 930 divided by 3, because there were 3 of them here. And so 930 divided by 3 equals 310. That's why I put 310 inside each one of these. If I put 310 inside each one of these units are the same amount. So this one had 310, this one had 310. So because we had our ratio of 2 to 3, it helped me to do a tape diagram and then to figure out how to separate and divide the 930 meters. If there were 310 here, 310 here, that meant Mason ran 610 meters. Going back to our question, if Lily ran 930 meters, how far did Mason run? Well, Mason ran 620 meters. I'm going to go ahead and write that over here. Mason ran 620 meters. And that's the answer to my question. Up here, we need to put an answer down here. If Mason ran 4 miles, how far did Laney run? Well, I'll even make it better. If Mason ran 4 miles, Laney ran 6 miles. And now I've answered both my questions in a complete sentence, which I really like to see complete sentences when we're answering questions. So those are my answers. Now you have another one. What ratios can we say are equivalent to 2 to 3? Remember that our first ratio, when we come way back up here, that Mason and Laney were running was 2 to 3. So if our first ratio is 2 to 3, what's the ratio for this one? And then for this one. See if you can't figure that out and then write it down here. Well, very good. The ratio that's equivalent to 2 to 3 is 4 to 6. And then, yes, 620. I know it's a big number, but it can be a ratio. 620 to 930. Those ratios are equivalent. Okay, now for exercise 4, I'm going to read it with you, but then I'm going to let you go off and work on it on your own. Josie took a long multiple choice end-of-year vocabulary test. The ratio of the number of problems Josie got incorrect to the number of problems she got correct is 2 to 9. If Josie missed 8 questions, how many did she get correct? Draw a tape diagram to demonstrate how you found the answer. That is just the same as we did in exercise 3, with the exception of our context is a little different. Looking at B, if Josie missed 20 questions, how many did she get correct? Use a tape diagram to demonstrate how you found the answer again. What ratios can we say are equivalent to 2 to 9? That would be this original ratio of 2 to 9, the number that Josie got incorrect to the number of problems she got correct. Come up with another possible ratio of the number Josie got incorrect to the number she got correct. So you get to come up with your own there. And then, how did you find the numbers? What did you do to figure it out? And F says, describe how to create equivalent fractions. That's probably the toughest one. I want you to really give that one some thought. Okay, so hopefully this is how you did it. I went ahead and made two tape diagrams based on the ratio that she got incorrect to the number of problems she got correct. So incorrect was 2. Sorry, correct? Yeah, incorrect was 2 and correct was 9. So when I made my 9 boxes, I then put that if she had 8 questions that she missed. If she missed them, it means that was incorrect. So if she missed 8, and I needed to put it into these 2 boxes, I can do 8 divided by 2 and find out that it's 4. 4 goes into each box. If 4 goes into each of these boxes or units, then they have to also go into all 9 of these. Then to find out how many she has correct, I can multiply 4 times the number of units we have, or number of boxes, and that was 36. So that told me that if Josie missed 8 questions, then she got 36 correct. Now you did it on Edpuzzle, and you should have gotten the correct answer if you put 36 in there. Now if you got any of the other ones incorrect and you're not sure why, feel free to go ahead and send me an email or see me in class about it. I'd like to go over the lesson summary right now. Based on our lesson summary today, we learned that 2 ratios, A and B, that can be a ratio, and then C and D could be a different ratio, are equivalent ratios if there is a non-zero number, C, such that C is C times A and D equals C times B. So for example, 2 ratios are equivalent if they both have values that are equal. It can be easier seen when we start looking at them in terms of with fractions as well. Ratios are equivalent if there is a non-zero number that can be multiplied by both quantities in one ratio to the corresponding quantities in the second ratio. And what that means, if we come back and look up here, was when we were looking at, way back up, and we're looking at our table, we said if we can multiply the number here and the number here, we will get the next number. So if we multiply both of these by 2, this one by 2, and 3 by 2, we get the equivalent fraction of 14 to 6. If we multiply 7 by 3, 7 times 3, and 3 times 3, we get the equivalent of 21 and 9, because 3 times 3 is 9. So when you multiply both parts of the ratio by the same number, you can then get an equivalent ratio. That is what this was saying to us in our lesson summary. Take a minute now and get ready for your exit slip. Okay, our exit ticket today is this problem. Pam and her brother both open savings accounts. Each begin with a balance of $0. For every $2 that Pam saves in her account, her brother saves $5 in his account. So that's the information we need to know. I'm going to come over here and fix this up a little bit. First question is, determine a ratio to describe the money in Pam's account to the money in her brother's account. The first thing we have to do is come up with a ratio about this. Okay, number 2 says, if Pam has $40 in her account, how much money does her brother have in his account? Use a tape diagram to support your answer. Since you can't do a tape diagram on a puzzle, you will have to show Ms. Shaw that you did this using a tape diagram, as with the other papers that you did, either on your document or on paper. But you will be able to put an answer into Edpuzzle. Okay, number 3 asks you to record the equivalent ratio. What they're referring to is the ratio that you came up with in number 2 from your tape diagram. What is that ratio in number 3? That ratio is equivalent to the one in number 1, if you did it correct. So number 4 then asks, create another possible ratio that describes the relationship between the amount of money in Pam's account and the amount of money in her brother's account. Basically, it's asking you to record an additional ratio from the one we got in number 3, the one we started off with number 1, and then number 3 had an equivalent one. Number 4, we need to come up with 2 more possible ones. Okay, now either you have the problem set in your book for math, on your paper, or you have it in a document, or you're going to Google Classroom and you're going to do what they have there for a problem set for your homework. Thank you very much. This is Lesson 3.